Alright, hello again. Back in the same night, once again. Okay, so we were last looking at... What were we last looking at? Not that, we were looking at... the selecting a GPU, the physical device. And we got that working. We actually selected our... Well, for me, my only GPU, but a GPU nonetheless. And now we're going to do this Q family stuff. So, it's been briefly touched upon before about that almost every operation in Vulkan, anything from drawing to uploading textures, requires commands to be submitted to a queue. There are different types of queues that originate from different queue families, and each of the family of queues allows you to it allows only a subset of commands. Okay, so certain commands have to go to certain family queues. For example, there could be a queue family that only allows processing of compute commands, or one that only allows memory transfer related commands. We need to check which queue families are supported by the device and which one of these supports the commands that we want to use. For that purpose, we'll add a new function called find queue families that looks for all the queue families we need. Right now we are only going to look for a queue that supports graphics commands. So the function we look for is something like this. Okay, let's steam on ahead without thinking and return a U32 from find queue families, and it's VK physical device. There's our prototype done. And let's throw it, where are we going to throw it? Check violation support. Let's actually put it next to, the rate device function. Okay. Alright, so there's some logic to find graphics queue family. However, in one of the next chapters, we're already going to look for yet another queue. So it's better to prepare for that and bundle the indices into a struct. Okay, a struct called Q family indices. So we have this graphics family, and I'm assuming we're going to have some other kind of family. Okay, so we're not going to return a U32 anymore. We're going to actually return a Q family indices struct. So thanks for making me write that without bothering to explain why we didn't need to write that. Let's create another struct next to our other struct. So all the structs can meet together in struct town. Type def struct Q family indices. And what's it gonna have? A U32 for graphics family. Gamily. Alright. Okay. So in here, it's actually going to be one of those and indices. Pardon me. And then logic define the Q family indices to populate struct with. Okay. This actually returns indices. Indices. Spelling, fantastic. But what if a Q family is not available? We could throw an exception. No, we couldn't in C. In the find Q families function, but this function is not really the right place to make the decisions about device suitability. No, we had a function for that and we deleted it in the last video. For example, we may prefer devices with a dedicated transfer Q family, but not required. Therefore, we need some way of indicating whether a particular Q family is found. Okay. It's not really possible to use a magic value to indicate the non-existence of a Q family. Hello, optional types. Since any value of a U32 could in theory be a valid Q family index, including 0. Right. Luckily, C++ 17 introduced a data structure to distinguish between the case of a value existing and not. And it's called an optional, which is like an abstract data type, if you're a functional programmer. Which I kind of am, but it's a bit tricky to do that in C. Well, we do not have that in C. So we have to come up with something else. Okay, this is just explaining how optional types work in C++. But that is some hideous syntax. But hey, it doesn't matter. The optional type is a wrapper container, no value, yeah, and so it's a value that either has an inner value or not, basically. And you get this secret hidden virtual maybe function called hasValue. Okay, so they want us to do in our struct, it's gonna change this U32 to a graphics, to an optional type. Well, that's gonna be a challenge for me because we don't have those optional types. Let's come back to that. We can now begin to actually implement our find Q families with nothing. All right. The process of retrieving a list of family Q families is exactly what you'd expect, and uses the get. Oh, that'll be enumerate, but we can get physical device family Q family properties. Oh, I am not typing that out. Where are we putting this? Okay, in here. So we have our U32, which is the Q family count. Initially it's 0. Then we pass in our Q family count to this function, along with the device. Well, I pointed to that, sorry. And null. And then I'm assuming we're going to call that again, and we're going to be passing in, that's right, a vector, well, a list of VKQ family properties. Fabulous. Okay, and we're going to call it Q family properties of that particular length. Okay, excellent. So then we're going to pass that in there instead of null. All right, and that will populate this to be a list of Q family properties. So the VK family properties struct contains, already got it open, contains some details about the Q family, including the type of operations that are supported and the number of Qs that can be created based on that family. We need to, there's a limit to the number of Qs you can create on a family. Okay. We need to find at least one Q family that supports VKQ graphics bit. Okay, let's take a look at this struct. It's got VKQ flags, a Q count, which I'm assuming changes depending on how many Qs you add to it. The timestamp valid bits. What's that? This is an unstandard integer count of meaningful bits in the timestamp written via VK command write timestamp 2. Whoa, that is way above my current pay grade. Minimum image transfer granularity. What's these Q flags? Q flags is a bit mask of VKQ flag bits, indicating capabilities of the Q in this Q family. Okay, what's that? That's a struct. No, that's sorry, that's an enum. With these keys and then a hexadecimal bit representation. Okay, no idea what the hell any of that is, but let's just continue as if we do. So we loop through all of our Q families and we figure out which Q flags are bitwise and to this VKQ. Oh, is that in here? It is. So we do a bitwise and on this, and it should be a truthy value. Wow, I don't think I could figure that out from just the docs. Okay. Oh man, wrong key. So for int I equal to 0 if I, or while I is less than the Q family count, increment I, and if Q family properties at position I dot Q flags bitwise and VK Q graphics bit. Okay, so if that is truthy, then indices dot graphics family equal to I. Okay, cool. Now that we have this fancy Q family lookup function, we can use it to check if the use it and check in is device suitable function to ensure the device can process the commands it wanted to use. All right, so that will return our indices. Oh, we haven't got a is device suitable. We were actually using the score function, so I guess we could probably put it in the score somewhere. What should we call it? Check device supports required Q families. Okay. So then this has a value. Oh, so we're returning if the indices dot graphics family has a value, which is this optional thing, which we do not have. To make this a little bit more convenient, we'll also add a generic check in the struct itself. Hey, what? Is complete. What's the difference between doing that and just accessing this with has value? Okay. Now we can also use this for an early exit from the find Q families. If indices is oh, okay. So the whole struct is complete if. Oh yeah. Oh, that's weird. Firstly, that's odd. When you already, what's the point in using an optional? Okay, strange C++. Let's not bother. If we wanted to do an early exit, surely we would just say once we found that, then just break, right? Wouldn't we? I guess unless in the future is complete has additional checks that I don't know about. Maybe. Well, let's just do this break for now, and then we return this struct. And then we're going to call this. Where are we calling it? Oh, we're calling it here. So then we would do a check to say something like if our indices dot, what was it called? Graphics family. We're not going to be able to do is null to check if it exists or not, because then if it didn't exist, we would just set the score to be 0 and say printf. Oh, well, let's just printf for now anyway. Q family not supported. And let's compile that. Build. Oh, hello. Yeah, comparison between pointer and integer. So null is the pointer, and this is an integer, even if it's null. Well, it isn't going to be null. Well, it might be null. So instead of an optional type on an integer, I wonder, well, why don't we, instead of doing this extra like optional and then also this is complete thing, why don't we just do our own is complete, which is a boolean of is this set is or has graphics family. Wait. Yeah, let's just do that. Okay. So then when we're using this somewhere here, we'll just set that to be initially null. Whoops, that is not how you do that. Our indices, yes indeed. Oh, I'll tell you what, we can actually just do this. Right, let's do indices dot graphics family that, and indices dot is graphics family set true. I wonder if we have to initialize it to null first, and I wonder if the boolean would default to false. Excellent. So now in this function call, which is here, we can say is graphics family set. If it's not set, then we want to set the score to 0. Okay. Right. But it works. It does. It is. We've set it. So we have got support. But just to double, triple, quadruple check, which is always good because you can count a lot of the big numbers, let's actually say here printf found Q family support. Yay. Found Q family support. Yay. Twice even. No, how many GPUs have I got? Okay. Great. No need for fancy schmancy optionals. We just create an extra element. I do have a feeling that maybe integers on a struct or booleans on a struct aren't a great idea. Vaguely remember hearing a talk on that or something, but we're not going for massive performance yet, so this is only initialization of Vulkan. There's definitely things we can improve on. Okay, so I think we're kind of done. That was a quick early wrap. Nice. Let me clear that, git add, wait, git reset, git add main, let's see, git status, git commit, what do we do? What was it called? Yeah, just family queues. Checked for support of family queues. Git push origin main. Excellent. That'll do for today. Thanks very much. See ya.